Bismillahirrahmanirrahim. My name is Muhammad on Munir, roll number 21T05. Our instructor is Dr. Muhammad Jamil. Today I am going to discuss about lab 5 of DSP. So moving to our task 1. In task 1, first of all we define a function which is my DFT, then defining length, then defining zeros, then starting k loop from 0 to n minus 1, then starting another for loop, then that is n is equal to 0 to n minus 1. Then we define a function that is a built-in function in MATLAB, that is y of k plus 1 is equal to y of k plus 1 plus x of n plus 1 into exponential of some value. Then ending for loop. Now we defining inverse DFT, same like previous one. We defining length, then defining zeros, then starting for loop from n is equal to 0 to n minus 1, then starting another for loop that is k is equal to 0 to n minus 1, then defining built-in function. Then end up the only difference in DFT and inverse DFT is minus sign, plus there is another x of n plus 1 is equal to x of n plus 1 over n. Then ending that for loop, then we define 4x, defining each of them. First of all we define 1x, that is 0 3 4 5, then defining y is equal to my m dft. Then we display the dft coefficients using display built-in function of MATLAB. Then calculate the inverse DFT, that is we define x of resin is equal to my inverse DFT. Then we display the reconstructed sequence, display IDFT sequence, so we get an output. Before that we take second x, again defining y, then display the DFT coefficient, then calculate the inverse DFT, then display the reconstructed sequence, then taking third x, that is 1 2 3 2 2 3 4 1 2. Same like previous one, we define my DFT, display the DFT coefficient, then display the inverse DFT, then display the reconstructed sequence, then taking last x range, that is 1 0 minus 1 minus 2 0 1 1 2, then display my DFT, display the DFE coefficients, then display the inverse DFT, then display the reconstructed sequence. As a result we get 4 output. We define each of them sequentially, so output 1 is like that. We get DFT coefficients and we get a inverse DFT sequence. Now moving toward output 2, we get DFT coefficients as well as we get a IDFT sequence. Then moving toward output 3, that is DFT coefficient plus IDFT. Move toward output 4, we similarly get a DFT coefficient plus IDFT coefficients. This is task 1. Now moving toward task 2. In task 2 we have a range of x from x1 to x11. We define each of the sequentially, then use figure for figure this, then we plot, that is we use temp command, then give title. As a result we get an output, that is of title x9 and n, that is samples, that is 32. Now moving toward task 3. In task 3 we use some built-in function of MATLAB, that is FFT, that is fast Fourier transform, that is we define x 1 2 3 4, then used built-in command of MATLAB of fast Fourier transform. As a result we get an output. Secondly we plot actually real terms, for that we use x real, that use similarly x, as a result we get x real. Then we found x imaginary terms, of x. As a result, we use built-in function. As a result, we get 0 to 0 minus 2. So finally, we get absolute terms of x. For this, we use built-in function, that is abs. As a result, we get absolute terms of MATLAB. Now moving to our task 4, which is same like task 2 with some iteration. First of all, we define x from x1 to x11. Then we separately define x1 to x11 as an FFT, that is built-in function of MATLAB. So defining these from x1 to x11 as in terms of FFT, then we separately define each of them from x1 to x11 in magnitude, phase and power. So we define it from x1 to x11. Then after defining these, we plot all these. For this we use subplot 311, then use temp command, then give title, that is magnitude spectrum, x label for in x-axis and y label in y-axis. Then again use subplot, that is 312, then give title phase spectrum, x label frequency, y label radians. Then again use subplot 313 using stem, then give title, that is power, y label and x label. As a result, we get an output of magnitude spectrum, phase spectrum and power spectrum. So we complete up with lab number 5. These are tasks. So meet you again in the next video. Thank you. Allah Hafiz.